Part B is a different story. Part B asks us, what's the standard deviation? Now, fortunate for us, we don't have a probability distribution here, a probability model, so we don't need to multiply, square, add together all of these different things. Instead, we can just use the standard deviation from earlier. This time, we want to know the standard deviation for 3 dozen eggs. Now, unlike the standard deviation that we worked with before with data sets, we actually cannot just take our 0.5 eggs and multiply it by 3. We can't do that. Instead, we have to do a couple different things. It's a 2-step process, 3 if you're really counting. The first thing we need to do is start off with the standard deviation of x, which is 0.5 eggs. From there, we need to convert that to the variance of the 1 dozen eggs. When we're in the variance, we can do a lot of different things. For this type of math, we can actually take the 3 dozen eggs that we have and get our information using the variance here. So we can find the variance of 3 dozen eggs. So if we take this 0.25 and multiply that by the 3 dozen that we have, we get 0.75. Now, with 0.75 as the variance for our 3 dozen eggs, we can take the square root of that and end up finding the standard deviation of those 3 dozen eggs. So I'm going to use my red pen. Standard deviation of 3x is going to be the square root of that value. And what we end up with, using our calculator again, 0.866. As our new standard deviation for this specific problem. Number 37 is going to be a little bit of a long one, so we're going to need to use the whole whiteboard. I went ahead and wrote down some of the given information, and I'll read that for you now. The amount of cereal that can be poured into a small bowl varies with a mean of 1.5 ounces and a standard deviation of 0.3 ounce. A large bowl holds a mean of 2.5 ounces with a standard deviation of 0.4 ounces. You open a new box of cereal and pour 1 large and 1 small bowl. I went ahead and I wrote down the given information. The expected number of cereal for a small bowl, the expected number for a large bowl, the standard deviation of the both. Number 37, part A asks, how much more cereal do you expect to be in the large bowl? While this problem could be overthought by a lot of students, we can actually just take the expected value of the large bowl and subtract it by the expected value of the small bowl. I went ahead and I wrote it up here like this, so that way you don't get too confused. You can also write it expected value of the large, expected value of the small, and we end up with the solution of 1.5 and 2.5, the difference between them, which is equal to around 1 ounce. Part B says, what's the standard deviation of the difference? It wants to find the standard deviation of the difference between the two. Now that's a little bit of a harder problem. What we didn't quite talk about yet is that in order for us to find the standard deviation, we need to first find the variance of the two values. So before I talk about anything else, we're actually going to find the variance. So the variance of a small bowl is going to be 0.3 squared, which is 0.9. Then we're going to find the variance of the large bowl, which is 0.4 squared, which is 0.16. Oh, I'm sorry. 0.09 and 0.16. Now, the difference between the variances is actually the same thing as the sum between the variances. It's the way that the math works out. So in this specific problem, we're actually going to go ahead and add those two values, and we get 0.25. And we're going to take the square root of the whole thing, which equals 0.5, which is going to be the standard deviation of the difference between the two values. Part C of the serial problem asks, if the difference follows a normal distribution model, what is the probability that the small bowl contains more cereal than the large bowl? This one's a little bit of a harder problem to answer because we need to go back to our normal distribution model in order for us to find it. We can start with drawing ourselves a normal distribution, and right in the middle, we're talking about the difference. We can put in our expected value for the difference, which is 1 ounce. In order for us to find that answer, the small bowl will contain more cereal than the large bowl when the difference between the two is less than 0, which means when we take the difference between the two, the large bowl and the small bowl will have the exact same value if the difference is 0. So in order for us to see if the small bowl is going to have more value or more cereal than the big bowl, our answer needs to be negative. So in this case, 0 ounces would be here having a net value of 0. We need to find any values negative in order for us to prove that our cereal will have, in fact, more in the small bowl than it will in the bigger bowl. In order for us to find that, we need to find the z-score of the value that we want minus the expected value over the standard deviation. And when we do this value, we're going to take the z-score of 0 minus 1 all over the standard deviation that we found, which is 0.5. When we do this, we end up with a value of negative 1 over 0.5, which equals negative 2. When we use our blue sheet and we look for a z-score of negative 2, we end up with a probability of around 0.023, or you can call that 2.3%. Part D asks us, what are the mean and the standard deviation of the total amount of cereal in the two bowls? So what part D is saying is, what happens when you put them together? If we follow the same situation as we did before with finding the difference, we can go ahead and take the expected value of the large bowl and add that with the expected value of the small bowl, and we get a value of about 4 ounces. The standard deviation follows a similar way. It's actually going to be exactly the same as our problem before of 0.5. Because the difference between the two bowls' standard deviation and the sum of the standard deviation of both of these cereal bowls are actually going to be the exact same value. Part E goes back to the normal distribution, and it says, if it follows a normal distribution model, what's the probability that you poured out more than 4.5 ounces of cereal in the two bowls together? If once again we take our normal distribution with now an expected value of 4 ounces, we can highlight or guesstimate around where 4.5 ounces is going to be. We want to find everything above that. Now, if you remember, when we find the z-score of this, our blue sheet only tells us the values of everything below that value, or below this z-score. We need to find everything above it. So let's start. The z-score is going to be 4.5 minus 4 over 0.5, taking into account our expected value and our standard deviation, and comparing it with the value that we want to compare it to. We can simplify that. 0.5 over 0.5, which equals 1. When we use our blue sheet and we go ahead and we find this value, we will actually notice that our blue sheet tells us the value directly below. So using the blue sheet for a value of 1, that will in fact give us an overall value of 0.841. And we need to find the converse of that. We need to subtract 1 by it, which will give us a value of 0.159, or 15.9%. That will actually have more cereal in the two bowls combined than 4.5.